Let us now explore how do we use product to sum trigonometric formulae to prove an identity. Enjoy the journey of learning. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to share with you a question from our student in Nigeria. I've seen that the standard of schools in Nigeria is pretty high. You can see from the example which we are going to solve. As you know, in my YouTube channel, we have participants from more than 80 countries, and we really cater to international needs, not just Canada or US. Now, when I'm going to solve this question, solution is the basic thing which I'll be providing. But apart from that, what we need to understand is how do we approach? What all should we know to answer such questions? So, here, let's discuss this question where we need to prove trigonometric identity sin A plus sin B plus sin C equals to 4 times cos A by 2, cos B by 2, cos C by 2, where A, B, and C are angles in triangle. So, from this statement, you can actually understand many things. We look into all this while solving the question. Well, let me thank all the viewers and subscribers for watching my videos, posting excellent comments and suggestions. You have made this channel worth watching. We provide the solutions which you need. And some of you who want to study from me, you can send an email on globalmathinstitute at gmail.com. During summer, we are going to run summer program, help students do better in the coming semester. You can enroll for the same. This email will work for many such things. Now, let's look into the problem and understand how should we solve such a question. Well, you see, sin A plus sin B plus sin C equals to 4 times product of cosines. That simply means that we should know what kind of formula translates sum to product, correct? That is one thing. If you know this, half of the question is solved. Now, what else is given to you? We know A plus B plus C are angles in triangle. That means what? That basically means that A plus B plus C is 180 degrees. So that is very helpful to know. I could actually relate the angles. For example, I can write C as 180 minus A plus B. You get the idea, right? So our angles can be related. So now let us summarize the formula known to us, which will translate from sum to product. So sine, right? So let's write down the formula here, make a note of these. So if I have sine of x plus sine of y, I could always rewrite this as equivalent to 2 times sine of x plus y by 2 times cos of x minus y by 2. Is that clear to you? Now, in case we have sine x minus sine y, then the formula becomes 2 times sine of, rather, what we do is we first write cosine, standard way. Cos of x plus y by 2 times sine of x minus y by 2. You see, Sum of sine has been now translated to product of sine and cosine. Now let's write down the formula for cosine, right? Cos of x plus cos of y can be written as 2 times cos of x plus y by 2 times cos of x minus y by 2. And when we have cos of x minus cos of y, it is negative 2 sine of x plus y by 2 times sine of x minus y by 2. Is that clear to you? So that is the fourth set of formulae which we are going to use. Also remember that cos of, let me write here, minus theta is cos theta. Since cos is an even function, sine of minus theta is minus sine theta, right? Perfect. So with that, you can actually solve the question, then look into my suggestions. Perfect. Okay, let's go through the solution now. So we'll begin with the left side, where we are given sine of A plus sine B plus sine C, right? So A and B we can combine using the formula we just discussed. So we get this as equals to 2 times. So it is sine of A plus B. When you do, we get sine and cosine terms, right? So it is sine of A plus B by 2 times cos of A minus difference, right? Plus sine C, correct? So we get these two expressions. And now, moving forward, we'll use the property that A, B, and C are basically angles in a triangle. So A plus B plus C is 180 degrees. And therefore, we could rewrite this as sine of A plus B can be written as 180 minus C, right? And here we have cos of A minus B by 2. We have sine C. I hope you also remember what is the formula for sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So we're going to apply this formula and rewrite this as 2 times sine of C by 2 and cos of C by 2. You see that? So we applied the double angle formula to write by C by 2 form, correct? Now we can write this as 2 sine 180 by 2 is 90 minus C by 2. And here we have cos of A minus B by 2. And we also wrote sine C as 2 sine C by 2 cos C by 2. Perfect. Now, sine 90 minus theta, as you know, is cos theta, right? This is a co-function identity, right? Which is sine 90 minus theta equals to cos theta. So we could write this as 2 cos of C by 2. And we have cos of A minus B by 2 plus 2 sine C by 2 and cos C by 2. Correct? So we got all this. So as you can see, we can take 2 cos C by 2 as common, right? We'll move on to the new page, taking these terms common, right? And within the bracket, we'll be left with cos A minus B by 2 and sine C by 2. Perfect. So let's move forward to a new page. So we'll rewrite the left hand side as equal to 2 cos C by 2, and we get sine, sorry, let's see that. We get cos A minus B by 2 plus sine C by 2. We get cos A minus B by 2 plus sine c by 2, right? We took cos c by 2 common. Now, again, sine c by 2 will rewrite as, you know, 180 minus a plus b, right? So we could go back and redo the same steps which we did earlier. So we could write c as 180 minus a plus b, correct? So that's what we get. So that gives you cos of c by 2 equals to cos of a minus b by 2 plus sine of 80 by 2 is 90 minus a plus b by 2. Makes sense, right? And that gives you 2 cos c by 2. And here we have cos of a minus b by 2 plus sine 90 minus theta is cos theta. Cos of a plus b by 2. Perfect. So now we have sum of cosines which we'll write as a product. We already got first part of it, which is this, right? The other two, we have to write it as a product, applying the formula, right? So now we have cos a minus b by 2 plus cos a plus b by 2. So when you add them up and applying the formula, we get cos sum of these and cos difference of these, right? So on the next page, we will write down. So what we get here now is that is equals to 2. Cos c by 2 is outside, right? We get cos sum of a minus b by 2 plus a plus b by 2 over 2 times 2, right? Do you see that? Times cos of a minus b by 2 minus a plus b by 2 over 2, right? Do you see that? So which gives us 2 times 2, I can take outside cos of c by 2. Here, a plus a becomes 2a, b and b cancel, right? So we get here cos of a by 2, right? And on this side, a minus b and minus of a is cancelled, and we get cos of minus b by 2. Now, cos is an even function, and therefore, we get our result, and that is cos of c by 2, cos of a by 2 times cos of b by 2, which is the right hand side, right? Makes sense. So basically, what we did was we utilized our formula of converting from sum to product in getting this identity proven. Hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, be great. And in case you want to learn directly from me, get ready for future. Send an email on globalmathinstitute@gmail.com. Thanks and all the best.